Learning objectives. Introduction. Classification of statistics. How statistics works. Need of statistics. Importance of statistics. Limitations of statistics. Summary. Suggested readings 1. Learning objectives. The objective of this module is to give basic introduction of statistics, and an attempt has been made to explain its meaning and concept as well as its importance for other sectors. Examples given in this module will help the learner in understanding this topic very easily. 2. Introduction. Statistics is a science that uses different tools and techniques to organize the data in the descriptive form, in the form of table, graphs and pictorial presentation, and extract information from the data that helps in making decisions. Statistics is considered as a study of collecting, analyzing, interpreting, presenting and organizing the data. Definition. Statistics consists of a body of methods for collecting and analyzing data. Agresti and Finley, 1997. Statistics is basically used to get insight into the data. Statistics helps to get an overall picture of an objective from the data based on graphical presentation or numerical calculation without any constraints on the number of observations. It not only gives graphical representation but also makes inference and predict relations among variables. For example, opinion polls for election involve designing of questionnaire then collection of data from the field with appropriate sampling methods. Further collected data is analyzed using statistical methods. At the last, the results are present in an understandable manner. 4. Statistical applications in environmental sciences. Self-check exercise. Question. What is statistics? Answer. Statistics deals with collection of data related with an objective, its analysis and finally its interpretation that is understandable by all the concerning persons involved with the objective in a direct or indirect manner. 3. Classification of statistics. Statistical methods have different branches and each branch has its great importance in the literature as well as for practical point of view. The following model explains the relation between these methods. From the above model, one can see that for statistical methods are segmented into two methods. One is descriptive statistics and second is inferential statistics. 3.1 Descriptive statistics. In descriptive statistics, graphical representation methods like histogram, bar chart, pie chart, ogive curves, box plot, line chart, etc. are used to present data in graphical form. Descriptive methods also deal with the summary of the data. This includes these following measures. Statistics. Descriptive statistics, inferential statistics. Graphical representation. Central tendency, dispersion. Correlation, regression, etc. Estimation, testing of hypothesis. 5. Statistical applications in environmental sciences. Central tendency measures. For example, mean, median, mode. B. Measure of dispersion. Variance, standard deviation, range. There are other measures like skewness, kurtosis, quartiles, quantile, percentile, etc. These measures are used to study other characteristics of the data. In descriptive statistics, one can study the scatterplot, correlation between variables, regression analysis. Basically, descriptive statistics deals with quantitatively describing the features of a data available from the sample population. 3.2 Inferential statistics. Descriptive statistics is used just to represent the information available in the data. But sometimes it is difficult to collect all the observation in the study for analysis. In this situation, sampling technique is used to collect element of the population in a non-random, random manner. Then inferential statistics is used to extract information from the sample as well to test the significance of an objective based on observations using testing of hypotheses. It is further segmented into two parts. These are estimation. Estimation techniques is to extract information about the population from the sample. B. Testing of hypotheses. This method is used to test the significance of a statement about a problem. In this section, a brief introduction of statistics methods are given to give a broad picture. It is not expected from a learner to understand each and everything at this stage. In future modules, an attempt has been made to elaborate these methods with examples. For time being, just keep in mind the basic difference between descriptive and inferential statistics. 4. How statistics works. In a very simple language, statistics is basically used to find solution for an objective or a problem in different areas. For e.g., if a person is interested in calculating the height of the students of college in particular region of a state for study. Now the question is how to approach this problem. The first thought that come to your mind is how we can say anything about the height among college students as there is variations in heights among the students. Now, what to do? 6. Statistical applications in environmental sciences. Figure 1. By using statistical methods, tools and techniques, one can find a numerical value that can help a person to find out solution. In this case, one can use very simple method that is measures of central tendency for e.g. mean, median, mode. Mean is generally used method in our daily life and is considered as the average of given values of a thing that has same characteristics. So take a mean of the values and see the outcome. The outcome will depend on the observation that we have. If the observations have little variation in term of height, then average mean value is very close to observations values. If the observations are not homogeneous, similar in terms of height, then the average value is different from observations values. For e.g., the values of the height of the 8 students in feet are 5 feet 2 inches, 5 feet 4 inches, 5 feet 6 inches, 5 feet 3 inches, 5 feet 6 inches, 5 feet 3 inches, 5 feet 5 inches, 5 feet 6 inches, and their mean value is 5 feet 4 inches approximately. If the values of the height of the 8 students are 4 feet 3 inches, 4 feet 9 inches, 5 feet 9 inches, 4 feet 1 inch, 5 feet 1 inch, 4 feet 8 inches, 4 feet 5 inches, 5 feet 3 inches, and their mean value is 4 feet 8 inches approximately. Now from the above example, one can see that there is major difference between the mean values of the two data. Self-check exercise. Question. What is the reason? So what to say? Answer. When the observations are not same, then the mean of the data does not represent the given data. so the output value is different from the values given in the data. 7. Statistical applications in environmental sciences. Question: what to do in this situation? Answer: we have to look for other methods of central tendency measures for relevant answer in this situation. We will study this problem again in further modules. We will discuss it again in the future. 5. Need of statistics. In the previous section, we discussed a case about height of college's students and how to apply statistical methods with an example. In this section, we will discuss the need of statistics in our life. We are using statistics or basic mathematics intentionally or unintentionally in our daily life. There are many examples, like while buying any item from the market, people inspect a smallest fraction of an item to check the quality. In statistics, we call this selected item as sample, and whole lot of an item from which item is selected called as population. Nowadays, we are more dependent on information technology that enables us to develop different tools and devices for different purposes. For example, mobile phone manufacturer companies want to increase the credibility of their product. That will increase the branding of their company's name. For these reasons, companies spend a lot on the research and development department. To test the reliability of products, statistical tools and techniques based on data are used. But with increase in the complexity of the system, new tools and techniques are required which are more efficient and less costly. To fulfill the demand of data analysis, consistent research is going on to cater this need. Hence, there is consistent increase in the demand of statistics tools and techniques. We can see the descriptive presentation of data in day-to-day life. For e.g., one can see the charts and graphs of inflation, opinion polls, economic growth, etc. on newspapers, television and other communication resources. Figure 2 represents the trend of inflation per year from the year 2001-2006. In this figure, one can observe that in 2002 inflation was less than in 2001. There was an increasing trend of inflation from 20,012,004 and it declined till 2006. 8. Statistical applications in environmental sciences. Figure 2. The purpose of graphical representation helps and descriptive presentation helps understanding the objective in a better way. It is easy for a layman person to understand things. In this section, we discuss the need of statistics with an example. Self-check exercise. Question: how statistics affects your daily life activities? Answer: statistics helps in providing information that is hidden in the data either in descriptive form or inferential form. For example, sampling techniques are used while buying grocery items, vegetables and fruits in the market. Question: how statistics estimates the characteristics of population from sample data? Answer: in statistics, there are different functions, a formula of data values, available to estimate the population characteristics, but the one who estimates the population characteristics in more accurate manner is considered. There are some parameters, conditions based on which one can check the optimality of the function. For example, if one has to study the average expenses of a middle-class family on food in a particular small town, one can choose using sampling technique some houses from the list of available houses, then collect responses from them. This data is analyzed further to get an estimate of the average expenses on food. One cannot determine. 9. Statistical applications in environmental sciences. The average expenditure on meal of a middle person based on single value. Statistics methods also help to give an interval containing lower and upper values. So, one can predict that expenses on food lie between this interval. In the next section, we will discuss the importance of statistics in different areas. 6. Importance of statistics. In this section, we will discuss about the importance of statistics in different areas. As statistics has a great role in different areas like determining the existing status of per capita income, mortality rate, inflation, population density rate, etc. This is the reason that statistics holds a great importance in almost every field like industry, economics, mathematics, astronomy and nursing, and here we will discuss some of them below. In industry. In industry, statistics has its great importance. Industry growth depends on the demand and supply of goods, customer loyalty and market stability. Statistics helps businessmen to plan production by taking into account all the possible factors that affects the sale of goods. Quality of products can also be checked by using statistical methods. Hence, statistics has great importance in the working of an industry. In economics. Economics deals with the study of factors that affects the economy of the world. So basically, economics depends upon the figures of these factors, and with passage of time these figures keep on changing. Economists use statistical tools and techniques to predict these factors with accuracy. In economics, statistical techniques are used for the collection of the data and as well as for analysis purposes. Statistics is also used to compare the factors like demand and supply, import and export, inflation rate, the per capita income, etc. Economists use descriptive statistics tools like presenting data in tabular form, histogram, pie charts, etc. to present their objectives in more attractive as well easily understandable way. In mathematics. Statistics and mathematics are complementary subjects. In mathematics, we use descriptive statistics as well as inferential statistics like central tendency measures, dispersion measures and estimation, hypothesis testing, etc. In statistics, we use integration, derivative and basic algebra for analysis purposes. As mathematical tools and techniques can only give you most reliable results if they are based on strong evidence. Statistical methods are used for collecting these evidences with higher probability of more precisely. For example, to check the viability of a project introduced by a large firm is calculates using both mathematics and statistics techniques. Hence, mathematics and statistics methods are both enrooted with each other. Statistics is also called branch of applied mathematics. 10. Statistical applications in environmental sciences. In banking. Statistics has a great importance in banking field, as bank's principal duty is to deposit money of depositors and use that money for issuing loans to lenders. There are many factors like rate of interest, economy stability, etc. that determine the business of the bank. These factors keep on varying with time. Hence, it is very important for banks to predict these factors more precisely as possible. Statistics techniques play an important role in predicting these factors with higher probability. Also, statistics helps bank to predict defaulters of loans. For example, if the market will crash, then people will lose their confidence in the economy of the country as well as bank. Also, lenders will default on their loan amount due to lack of demand of their goods that will decrease their profit. Statistics can lower the bank's risk by predicting factors that affects the market. B. In administration. Statistical methods are basically used for collection as well as analysis of data and also for the interpretation of the results in different sectors of administration. In government offices, most of the projects for social welfare depend on its successful working. For example, if the government wants to increase the dearness allowance or revise the pay scale of employees due to increase in the living cost, statistical methods will be used to determine the rate of inflation that affects the cost of living. Also, central and state government budgets depends upon the statistical tools that help them in estimating income and expenditure from different sources. So statistics has a great importance in the administration's work. B. In accounting and auditing. Accounting is used by firms to maintain the balance sheets. It is based on data and it does not survive without the authenticity of the data. In accounting, statistics is used for decision-making purposes, for example, how to correctly quantify the assets of the company, liquidity value of the assets, how to calculate depreciation cost of the assets, etc. All these decisions are based on the market conditions. For example, all electronic assets value depleted within months due to high new technology development rate. B. In natural and social sciences. Statistics has its vital role in natural and social sciences. In natural sciences, for research and development purpose, laboratory experiments and field experiments are conducted. Information is gathered in the form of the data. Now, to draw conclusion from the data, statistical methods are used. For example, scientists are interested to test the effectiveness of newly developed drug for the heart patients. To test the effectiveness, they collect the information of health status of heart patient after taking dose of new medicine. It is possible. 11. Statistical applications in environmental sciences. That drug is effective for some patients and ineffective for others. So, statistical method, especially hypothesis testing, we'll cover in the coming session, is used to test the significance of newly developed drug for heart patients with some confidence. In social sciences, most of the research work is done with the help of questionnaire and field work. Statistics is used to test the reliability and validity of the questionnaire. It is used to analyze the data obtained from the questionnaire and draw inference from them. For example, most of the social workers collect information through questionnaire. These questionnaire are further processed and stored in the form of data. This data is analyzed further and draw conclusions. In field work, statistics also help social scientists to determine the sample size and to adopt which sampling techniques. B. In astronomy. Astronomy deals with the densities of heavenly bodies, masses, measurement of distance between stars and planets, their sizes as well as other activities in the space. If errors occur while calculation of these figures, that loss is unbearable for all. So, to avoid such type of errors, statistical methods are used. For example, from the old days, least squares method is used to find the movements of stars. X. In demography. Statistics is considered as a backbone of demography. Demography deals with the study of population structure, sex ratio, health status and age group among population. It is difficult to collect information from each individual. Statistical methods are used to determine sample size and sampling technique based on objective. For example, if a person is interested in studying the mortality rate of cancer patients in a state. For collecting data, person must have to determine the resources from where one can collect information. After that, appropriate sampling technique is used to collect samples. Based on these values, one can estimate the mortality rate of cancer patients in a state. 7. Limitation of statistics. Statistical analysis are mostly used for quantitative data. However, there are many tools available that can be used for qualitative analysis. It can only be applied collective and not on single events. Statistics give results on average basis that are true in the long run and not able to give result for a particular case. Statistical results are not % correct. These are just approximate values and not exact one. Statistics approach may not reveal the entire problem as some of the factors are incapable of statistical analysis. 12. Statistical applications in environmental sciences. Statistical methods may lead to wrong decision if not applied in a correct manner. Statistics tools, if applied in a wrong manner, can lead to major loss. In this section, we discussed about the importance of statistics in different fields. For more information, one can refer to the links given below. C4% B0 STAT% C4% B0 ST%. Summary. As from above, the statistics has great importance in almost every field, whether it is social sciences, natural sciences, and industry. The reason behind is statistics methodology is based on analysis of data sample or whole population. Due to increase in complexity and volume of data, it is difficult to extract information easily. So, consistent research is going on to develop methods and tools to overcome these problems. These days, most of the analysis is done using statistical softwares and programming languages. 9. Applications in environmental sciences. Module 2. Data and its types. Learning objectives. Introduction. Types of data. Comparison of qualitative and quantitative data. Variable. Summary. Suggested readings 1. Learning objectives. In this module, an attempt has been made to give a brief and relevant information about the topic with examples. This module helps to understand the various types of data and their segmentation. Numerical questions are included to give an in-depth knowledge of the topic. 2. Introduction. Data is a plural form of a word, datum. Data is considered as a collection of items either in qualitative or in quantitative form, and it consists of full information regarding the objective. It consists of relevant information about the objective, and it is analyzed further to extract that information. Data is collected from the sources in which one is interested. In different sectors, it is possible that one does not have direct approach to the object due to time and money, for example, for the study of an environment affecting factors. One requires large instruments and manpower to collect values, but there are other departments like metrological sciences, remote sensing that also deal with the same objects. Thus one can use published data by these departments for further analysis. The source that one has used to collect the data is secondary and it is called secondary source. If one has direct approach to the sources and information, then data collected is considered as from primary source. So data are collected from two sources. A primary source. B. Secondary source. Now information is collected in the form of data from one of the above sources. This information is further used for analysis purpose. It solely depends on the characteristics of an item that it can be observed either in quantitative form or in qualitative form. For example, height, weight and age of a person are quantified in numbers. This is an example of quantitative form, and the variables used to quantify values are called quantitative variables. Also, some characteristics like religion of a person, designation, severity of a diseases, gender etc. are difficult to calculate in terms of number, but one can assign numbers to them for recording purpose and has no meaning in term of value. For example, for noting down sex of a person, on can use 1 for male and 2 for female in a government survey. Similarly, for considering the health status of patient suffering from particular disease, one can categorize good as 1 foot, mild as 2, and severe as 3. This is an example of qualitative data, and it is further evaluated to draw conclusion. 4. Statistical applications in environmental sciences. The main thing that one has to keep in mind is 1 foot, 2, and 3 values assigned to different category are just representative values. It does not mean that one value is double or half another value. So one cannot apply mathematical, statistical methods on the values to make a decision about the study. In the coming sections, the detailed structure of the data and its types are discussed in detail. Self-check exercise. Question. Which source is used to study the factors affecting environmental pollution in the country? Answer. As from the objective, one can see that the area under study is very vast. So, it is difficult for a person to gather data within a limited time period and money. But one can find data related with the study from the report published by many government departments. Hence, secondary source is basically used in such cases. Question. Is it true to say that secondary source for data is always reliable for a study in environmental sciences? Answer. There are many things to discuss before making a comment about the statement. Few questions are: does one get secondary data from a renowned agency, government institution? Does one get latest data that one needs for a study? Is it also beneficial to take secondary data? If the answer is true in each of the above cases, then the statement is true, but it is not always true in general. 3. Types of data. In this section, an attempt has been made to give an understanding of types of data. One can get detailed understanding of types of data after reading this section. The following chart explains the different segments of the data and its relation with one another. 5. Statistical applications in environmental sciences. Figure 1. From the above chart, one can observe that data is mainly segmented into two forms, and these forms are further divided into various segments. One of main branch of data includes qualitative data, and it is further divided into attributes, nominal and ordinal. Similarly, quantitative data includes continuous data and discrete data. 3.1 Qualitative data. Qualitative data deal with information about the characteristics or qualities of an object under study that cannot be measured. For example, color of skin, shape and color of eyes. 3. Segmentation. Qualitative data are further divided into the following types. These are A. Attributes. B. Nominal. C. Ordinal. 3.1 A. Attributes. Attributes are considered as a type of qualitative data that have only two categories. For example, male, female, yes, no, dead, alive. It is called attribute data because of two categories. One can say whether an item has presence of attribute characteristics related with objective or not. For example, in a study of census, there are many items like male, female, excluding third sex, employed, unemployed, educated, illiterate, etc. are considered as attributes. 3.1b Nominal. Nominal data are considered as that form of data that cannot be ordered or have more than two categories. For example, color of hair, black, brown, blonde, etc. Marital status, married, unmarried, divorced, separated, nature of disaster, fire, theft, accident, earthquake, etc. In these examples, one can observe data. Qualitative data, quantitative data. Attributes, dichotomous, continuous. Data, discrete data, ordinal, nominal. 6. Statistical applications in environmental sciences. That there are more than two categories and these categories are unordered. It means that one cannot compare black color with brown color and comment about it. Also, one cannot compare categories of marital status and nature of disaster with each other. 3.1c Ordinal. Ordinal data consist of observation that can be ordered in terms of their characteristics. For example, tidiness among students have categories as messy, fairly, tidy or very neat. Build of body has categories fat, medium size or thin. Agreement has categories strongly agree, agree, neither agree nor disagree, disagree, strongly disagree. Now one can order observation based on these categories in terms of high or low level of cleanliness. Similarly, responses on body type and agreement can also be ordered based on categories available. Self-check exercise. In the following question, state the type of data with a reason. Question. Which one of the following subject you learn here? A. Mathematics. B. Physics. C. Statistics. Answer this question as an example of qualitative data, and further it is categorized as nominal data. The reason behind this is that one cannot order subjects. In the previous question, subjects are considered as a nominal data. But it can be ordered depending on the question. Question. Which of the following subject you like the most? A. Mathematics. B. Physics. C. Statistics. Answer. It is an example of qualitative data and specifically ordinal data, as one can order the subjects based on his liking. Question. How would you rate your learning technique? Answer. It is an example of qualitative data and specifically ordinal data as the categories are ordered from poor to excellent. Question. Did you study statistics in your college? Answer. Qualitative data and it is an attribute. In this case, we simply say item has this attribute or not. Question. How would you rate your learning techniques? 1 equals excellent, 5 equals poor. 7. Statistical applications in environmental sciences. Answer. It is an example of qualitative data and specifically ordinal data, as you can grade your learning techniques from 1 to 5. One can keep the above examples in one's mind for understanding the concept in depth. In the next subsection, quantitative data is explained with examples. 3.2 Quantitative data. Quantitative data consist of numbers e.g. 1, 0.8, minus 3.7, 3/4, are quantities e.g. 1.2 kilograms, 155 centimeters. Most of the books consider numbers being referred to as quantitative data. Quantitative data are further segmented into 2 types. These types are a. Discrete quantitative data. B. Continuous quantitative data. 3.2 A. Discrete quantitative data. Discrete quantitative data are that form of data that can only take particular numbers like whole numbers. For example, in a study of cancer patients, numbers of patients are calculated in whole numbers, that is 0, 1, 2, 3. One cannot count 2.3, 3.5 persons. There are situations where observation are considered in terms of whole numbers only, then they are examples of discrete quantitative data. Whole numbers are those numbers that start from 0 and go till infinity, that is 0, 1, 2, 3. 3.2b Continuous quantitative data. Another form of qualitative data is continuous data that can take all values, either it is whole number or real numbers. It considers negative values. For example, temperature of a room can be negative, positive or 0. Time duration of happening of an event like earthquake is considered in minutes and seconds, for example 51. 2 minutes, etc. Continuous quantitative data are basically derived while measuring height, cm, time, sec, etc. Self-check exercise. Question. State the type of data in the following. A. Weight of a student. B. Place of birth. C. Number of claim occurred due to natural disaster. D. Nature of loss due to natural disaster. E. Age in complete years. 8. Statistical applications in environmental sciences. F. Loss occur due to flood. Answer. A. Continuous data, quantitative data. B. Nominal, qualitative data. C. Discrete data, quantitative data. D. Ordinal data, qualitative data, as loss can be small, large or big amount. E. Discrete data, quantitative data. F. Continuous data, quantitative data. In this section, various types of examples on data are discussed so that one can easily understand the differences between types of data. Now, one gets an understanding of the qualitative data and quantitative data and its types. One more important topic that is related with this module is variable. 4. Comparison of qualitative data and quantitative data. In this section, an attempt has been made to give a clear understanding about difference between qualitative data and quantitative data through real-life situations. In a study to quantify loss occurred due to natural disaster in a state, how will one approach the total amount of loss? There are many types of loss like financial loss, human being, etc. One must have some instrument tools to quantify financial loss as one cannot measure loss of human being. So, one must have questionnaire or paperwork to collect information about financial loss. One can see the draft of questionnaire below to understand which data is covered under which form. The draft of questionnaire is: name, age in years, sex, occupation, type of financial loss, estimated financial loss, details. No, a family person's injured. No, a family member died. From the above questionnaire, one can observe that data hold both the qualitative and quantitative forms. Starting from considering age in years, discrete quantitative data. Sex, attributes, qualitative data. Occupation, nominal qualitative data. Farmer, shopkeeper, laborer, type of financial loss, ordinal qualitative data. Estimated financial loss, continuous quantitative data. 9. Statistical applications in environmental sciences. No, a family person's injured, discrete quantitative data. Number, a family member died, discrete quantitative data. From the above example, one can see that in real life the data consists of different types. Hence, one must be clear while preparing questionnaire or study about the type of items questions. So one can keep the following points in mind about qualitative data and quantitative data. These are: qualitative data, quantitative data. It helped to gain an understanding of the features of the data. It helped to quantify data and generalize results from the data of interest. It helped to provide insights of the problem, generating ideas for further research. To measure the incident related with various views and opinion. To provide view about the problem where complete enumeration based on numbers are not possible. Sometime followed by qualitative research that is used for further use. Hence, from the above comparison, one can observe that both these methods are also complementary to one another. The questionnaire has given above to prove this statement, as one can see that information is collected from the respondent to draw conclusions. These include results, statements about all the attributes and variables available in the data. For example, from the above questionnaire, one can conclude on the basis of data that X amount of persons, male, female, of Y age are affected with monetary loss of Z amount on average. This shows the relationship of loss amount with attributes like sex and variables like age. 5. Variable. Variable is another commonly used word when collecting information from the observations. Before looking at the definition, let's first understand it through an example. Basically, data or realization of the variable. For example, in a study of measuring average height of student, then height is considered as a variable, as height of each student is different and it can take any value within a specified range. Also for other objectives whose value vary under different conditions are measured through variable. For example, if there are 3 students and their heights are given in inches as 78, 81 and 56 respectively. So our data have 3 values and it is collected by measuring heights of students. Definition. 10. Statistical applications in environmental sciences. Variable is defined as a measurement tool that fluctuates its value with change in the conditions of an objective. In quantitative data form, observations are of discrete or continuous data form. Hence there must be 2 variables. These are 1. Discrete variables. 2. Continuous variables. 5.1 Discrete variables. As variable is considered as an instrument that can change its values. Discrete variables are those variables that can only change values in whole numbers. For example, numbers of boys in a class, number of patients in a hospital, number of accidents occurred in a year and number of states in a country. Definition. Variables that can only take on a finite number of values is termed as discrete variables. This value vary from one observation to the other. 5.2 Continuous variables. In the previous example, height of different person vary and also it can take values in decimals, so height is considered as a continuous variable. Thus continuous variables are those variable that measure the value of an item in real. Definition. A variable is a tool that keep on changing value. This value can vary from one observation to the other. A continuous variable is a variable that take any value possible for observation on the real line. It means all possible positive, negative, fraction, etc. There are uncountable values that exist between 2 numbers like 1 and 2 for e.g. 1.00, 1.01, 1.001. Following examples will give you more insight about continuous variable. These are time taken by a person to complete a task, height of a person, wind speed, dust particles in the air, cost of an equipment object, average speed of bike mileage of car. After understanding the definition of the variable, it is easy for one to understand independent and dependent variables as these variables are used in the most of the studies. 11. Statistical applications in environmental sciences. Independent variable. A variable is said to be an independent variable if there is little change in its value. The values of other variable change, but when the value of other variables change, then there is no change in the value of this variable. Hence, that variable whose value is not affected by any other variable is called an independent variable. For example, algal density is a variable and its value determine the quantity of chlorophyll that is used as an indicator of lake water quality. But change in chlorophyll does not have an impact on the value of algal density. In this case, algal density is considered as an independent variable. Dependent variable. A variable is said to be dependent variable if its value changes due to change in other variable. The variable that influences the value of this dependent variable is called independent variable from above definition. From previous example, one can see that there are quantities like algal density, pore water quality and chlorophyll 2 that is used as an indicator of lake water quality. Now, chlorophyll 2 value are basically dependent on the values of algal density and also on the quality of lake water. So basically, chlorophyll 2 is dependent variable and others are independent variables. Self-check exercise. Question. Which one is independent dependent variable in the study if a scientist conducts an experiment to test the theory that a vitamin could extend a person's life expectancy? Answer. Here the independent variable is the amount of vitamin that is given to the subjects within the experiment. Dependent variable is the variable affected by the independent variable and in this case it is lifespan. Question. If a scientist studies the impact of a drug on cancer, what will be an independent variable? Answer. A scientist studies the impact of a drug on cancer, hence it is a dependent variable. Here independent variables are the administration of the drug like the dosage and the timing of an impact. Question. If the scientist studies the impact of withholding affection on rats, which one is the independent variable? Answer. Here the amount of affection is the independent variable and dependent variable is the reaction of the rats. Question. In a scientific study that how many days people can eat soup until they get sick? Write independent and dependent variable. Answer. Here number of days of consuming soup is an independent variable and the dependent variable is the onset of illness. 12. Statistical applications in environmental sciences. 6. Summary. In this module, we try to give an in-depth knowledge of different types of data. Different types of data are discussed with examples that help the reader to understand the topic in an easy manner. In the 4th section, different data types are compared in terms of their feature and properties that they possess. Variables with their types are discussed due to the importance of this topic in the statistics. Question and answer part will help you to check understanding of this topic. 7. Module 3. Measurement scales. Learning objectives. Introduction. Numbers property. Classification of the scales. Comparison. Summary. Suggested readings 1. Learning objectives. In this module, an attempt has been made to give a brief and relevant information about the topic with examples. This module helps to understand measurement scales and its types and further related information. Questions with answers are included to give an in-depth knowledge of the topic. 2. Introduction. S.S. Stevens 1906-1973 used different scales of measurement to describe the data. These scales are used for different purposes based on the data and different features that it possess. A proper scale that is used to measure a variable has a great impact on the statistical methods or technique that can be used to analyze it for further inference. So generally, scientists want to use that measurement scale on a variable that explains the features of the data in exact manner so that one can apply the statistical tool appropriately. Researcher defined 4 different measures known as scales of measurement. These are A, nominal, B, ordinal, C, interval, D, ratio. Ratio scale has the features that other scales have. Thus one can say that each of these scales of measurement contains more features in increasing order, and therefore each succeeding scale of measurement is used for more sophisticated statistical analysis than the previous one. Before discussing about scales, there are some important properties of numbers that a person must be aware of. These properties will help the person to differentiate between scales in a better way. 4. Statistical applications in environmental sciences. 2.1 Numbers properties. Numbers are used for the presentation of the data. It is essential for a person to understand its 4 properties, and these properties determine how numbers can be used. These are: Identity. Numbers are used for identification only. For example, football player's t-shirt number is used for labeling purpose. One can judge the performance of the player with the t-shirt number. Another example is, different trains have different numbers. These numbers help you to find out the right train for your destination. Even in bike racing game, different bikes are labeled with different numbers to differentiate with one another. This will help you to know the performance of which bike and whose bike is it. Here, for example, bike number 1 is not numerically different from bike number 2. B. Magnitude. The second important property of a number is called magnitude. Numbers are used for identity purposes discussed in the previous section, and its value represent an amount of something. Also, larger number indicate more of this quality, then it is called magnitude property of number. 2 coins are better than 1 coin, 4 men are more than 3 men, etc. C. Equal interval. Some property of numbers are such that if it indicates amount or magnitude in such a way that the difference between numerical values has same meaning in the scale from all ranges. For example, the interval difference between 90 and 80 marks is same as the interval difference between the 70 and 60 marks. This number property allows some numerical calculations like adding and subtracting on the numbers. D. True zero. This property of number allows one to apply all the mathematical operations on the numbers that can be interpreted as well. There are some numbers that have a value of 0 that really means something. Having a value 0 does not mean the absence of the characteristics of the study in the number. For example, 0 degree temperature in a room does not mean the absence of temperature is 0 degree. 5. Statistical applications in environmental sciences. Temperature has its own meaning. However, on a length, weight scale, number of claims, etc. are the value in which 0 means really 0. These 4 properties are used by different scales, and based on these properties one can easily differentiate between different scales. 2.2 Classification of the scales. Classification of the scales is based on the data under study. Different measurement of scales are used for the extracting the information available in the data. Data are of 2 types, a quantitative data, b qualitative data. As we already discussed about the types of data in the previous module. So one can visit the material from previous module about different types of data and variable. We are going to use these terms here again to give more information about different scales of measurement. As in the previous section, we discussed 4 different measurement of scales. The first one is nominal scale. It is used for qualitative data. A nominal scale. A nominal scale of measurement is used for different categories like color, sex, nations, states, rivers, etc. Nominal scale is a scale that categorizes things into sections that are different in terms of qualitative features. For example, the categorization of the school teachers in terms of sex, religion, etc. are covered under nominal data. While filling any survey form or form of applying visa, school admission, college admission, passport, etc., we use different code to represent data such as sex, religion, etc. These are also examples of nominal data. As nominal scale assign number to different categories, it does not have any quantitative significance or value. For example, for analysis purpose, if we assign 1 digit to male or 2 digit to female. As sex can be described through quantitative figures, but digit has no quantitative significance here. It is used for further statistical analysis like diagrammatic representation of the data, counting of the number of observation of particular category. For example, in a survey of sex of school teachers, it is found that among total 200 teachers, 150 teachers belong to male category and 50 belong to female category. Hence, nominal scale is used for grouping of different categories. These observations can be processed further for analysis purpose. 6. Statistical applications in environmental sciences. Hence, nominal data are considered as that form of data that cannot be ordered or have more than 2 categories. For example, color of hair, black, brown, blonde, etc., marital status, married, unmarried, divorced, separated, nature of disaster, fire, theft, accident, earthquake, etc. In these examples, one can observe that there are more than 2 categories, as well as these categories are unordered. It means that one cannot compare black color with brown color and comment about it. Also, one cannot compare categories of marital status and nature of disaster with each other. The data values are assigned numbers for keeping record in a computer data file. For example, different types of blood groups A+, AB, O+, or recorded as 1, 2. And similarly, different types of accidents are recorded as 0 or 1, 1 or 2, etc. Here we can assign different numbers to categories, as number has no quantitative significance, it is just used for the representation purpose. There is no order associated with the data and arithmetic operations cannot be performed. Hence, we cannot add values of different categories as mathematical it seems to be relevant, but actually it is not relevant. For example, if we assign A+ as 1 value and A as 2 value. If we add 1 plus 2 it is equal to 3, but in actual we cannot club A+ in a group persons as they have different characteristics. Next we will discuss about ordinal scale. This scale is used in those cases where data can be categorized into different categories like nominal scale, but also these categories can be ranked based on the characteristics of the data. B. Ordinal scale. In ordinal scale, we are more concerned with the ordering of observations based on characteristics that it possess. It is also known as a scale that can order the data according to the relationship among the values of the characteristics of the data. For example, while categorizing the designation of the employees in a bank, we can categorize them as manager, assistant manager, clerical staff, etc. Here we can rank the employees based on their designation and assign numerical values to them, that is manager 1, assistant manager 2, clerical staff 3, etc. These codes are used for further analysis, but here the values have different meaning as used for. 7. Statistical applications in environmental sciences. Nominal scale. In nominal scale, sex categories male and female are not comparable, so the value 1 assigned to male and 2 to female are not comparable, but in ordinal scale minimum digit can be assigned to highest order category and maximum digit is assigned to lowest order category, or minimum digit can be assigned to lowest order category and maximum digit can be assigned to highest order category. It depends on the experimenter that determine the sequence of assignment of numerical values to different categories. As ordinal scale is applied to qualitative data in which observations are ranked in some order, but difference between data values cannot be determined or are meaningless. For example, if we order data in terms of designation and assign 1 value to manager, 2 value to assistant manager, we cannot use arithmetic operations on these data values as in nominal scale. Here difference of the numerical values has no meaning and cannot be interpreted. For example, if we take difference 1 to 2, the mathematics value is -1, but here negative value of 1 has no quantitative significance. Thus one should keep these things in mind while applying ordinal scale to the data. Ordinal data consist of observation that can be ordered in terms of their characteristics. For example, tidiness among students have categories as messy, fairly, tidy or very neat. Build of body has categories like fat, medium-sized or thin. Agreement has categories like strongly agree, neither agree nor disagree, strongly disagree. Now one can order observation based on these categories in terms of high or low level of cleanliness. Similarly, responses on body type and agreement can also be ordered based on categories available. Hence ordinal scale can be used for all cases where there are ordering in categories like height among students in a school, monthly salary of teachers, lecturers, professors, marks obtained by students in an examination, agreement, level of cleanliness, etc. Now we will discuss third scale, that is interval scale. As we already discussed that both nominal and ordinal scales are used for qualitative data. Due to this reason, the numerical values that we assign to 8. Statistical applications in environmental sciences. Data have not qualitative significance, but in the interval scale the values can be compared in terms of magnitude only but not in relative purpose. We will discuss this in detail in the following. See interval scale. In an interval scale, data can be arranged in some order and difference between the consecutive units have some quantitative significance. The interval level of measurement results from counting and measuring but not for comparing in terms of ratio. Hence in interval scale data ordering of the units and difference between the units can be calculated. As the zero values is arbitrarily chosen for interval data and does not imply an absence of the characteristics being measured. Thus ratio of the units cannot be evaluated for interval data. For example, IQ, intelligent quotient, score represent interval data. If one person A has IQ score is 80 and another person B has IQ score is 40. A has higher IQ than B and IQ scores can be arranged in an order. A IQ score is 40 points higher than B IQ score, that is IQ scores can be ordered as well as difference between IQ scores are meaningful. However, we cannot conclude that A's IQ is 2 times than B's IQ. As 0 IQ score does not indicate a lack of intelligence among the person. Hence one cannot conclude the units based on ratios in interval data. Hence in an interval scale of measurement is based on observations that are ordered as well or of equal length and zero value has its importance. Addition or subtraction is possible on this scale, but no multiplication or division. There are few examples of interval scale like test scores represent interval level data, temperature also represent level data, etc. D. Ratio scale. Ratio scale is a scale in which the observations are ordered and are of equal interval length with true 0 point. So that one can perform basic mathematics like addition, subtraction, multiplication and division except by 0 on the values. The ratio level of measurement results from counting or measuring. Ratio scale data can be arranged in order. Also differences, ratios of observations can be 9. Statistical applications in environmental sciences. Calculated and interpreted. Ratio level data has an absolute 0 and a value of 0 indicates a complete absence of the characteristic of interest. For example, length is a ratio variable. There is a true 0 number as 0 length means absence of length characteristics. Similarly, weight and speed are also ratio variable. Hence ratio scale is interpretable and consists of true 0 number. For example, the fat consumed per day by Indian is an example of ratio scale data. As youngster used to consume more fat than old. Hence consumption of fat is comparable among youngster and old age persons in terms of category, order, equal interval and relative. As different mathematical operations can be performed on the data. Hence the data belong to ratio scale. Another example, in a study of emergency call to ambulance in a particular state in a country with having a sample size of approximately 10,000 in a month. The call are received on daily basis and number of calls received as ratio scale data. Calls on a particular day can be compared with any other day in terms of ratio. Also no call means absence of characteristics. 3. Comparison between different scales. In the following section, we will provide you the summary of the measurement scales. In this section, features of the measurement scales are provided in points that will help the person to remember the features of different scales. It is also easy for a person to compare the features of different scales. A nominal scale. It is a level of measurement that is lowest among all scales and is mostly used with the data that are qualitative in nature rather than quantitative. Some of the important features of nominal scale are mentioned below. In nominal scale, the data is divided into different groups or categories. These groups or categories are assigned units, i.e. numbers, and objects are determined through the category or group to which they belong. In a nominal scale, one can assign different names to the category to which they belong, and for analysis purpose numerical values are used to represent these names. It is important to note that because the units of a nominal scale are categories, hence no arithmetic operations can be applied between the units of a nominal scale. 10. Statistical applications in environmental sciences. Also, there is no quantitative relationship between the categories. A basic features of the nominal scale is that of equivalence. Every member of a given category or group are same on the basis of classification. Experimenter often used nominal scale for categorizing the data into groups and also to count number of observation in a particular group and draw inference based on these values. These frequency value also help one in comparing the number of items within each group or category. A nominal scale does not possess any mathematical features like equal interval, absolute zero point, etc. It allows categorization of objects into mutually exclusive categories. B. Ordinal scale. Ordinal scale is the next higher scale after nominal scale. It is also used for qualitative data, but it has some other features than nominal scale, like categorizing data with order or ranking. There are some features of ordinal scale that are given below. It possesses a low level of mathematical property, like one cannot apply arithmetic operation on the data values. One can rank the category based on whether they possess more, less, or the same amount of object being measured. Although with ordinal scale one can compare the objects in terms of better than, equal to, or less than, but it says nothing about the magnitude of difference between adjacent units on the scale. It does not have the property of equal interval between consecutive units. It does not tell about the absolute level of the units, for e.g. all units belong to same higher category or lower category. Thus one cannot give any statement about the data in absolute term. C. Interval scale. It is higher scale than both nominal and ordinal scale. It is used for the qualitative data, but one can apply arithmetic operation like multiplication and division on the data having interval scale. Some of the features of interval scale are mentioned below. 11. Statistical applications in environmental sciences. The interval scale possesses the properties of magnitude and equal interval between consecutive units, but does not have an absolute 0 point. There are equal amount of the variable being measured between adjacent units on the scale. The interval scale possesses the properties of the ordinal scale and nominal scale. In an interval scale, equal differences between the numbers on the scale represent equal differences in the magnitude of the variable. It follows that greater differences between the numbers on the scale represent greater difference in the magnitude of the variable being measured. Also, smaller difference between the numbers on the scale represent the smaller difference in the magnitude of the variable being measured. The difference between the interval and ordinal scale is that in ordinal we can order the objects based on the characteristics, but difference between the numbers has no quantitative significance, but in interval scale one can order the observation and also take interval difference that has quantitative significance. D. Ratio scale. Ratio scale is the highest level of all measurement scales. It has all the properties all nominal, ordinal and interval scale and other features that differentiate this scale from other scales. These are: ratio scale holds the property of absolute zero. It means that a ratio scale data can be compared on the basis of ratio. Without absolute zero property, it is not possible to calculate ratio of the data and give interpretation. In ratio scale, equal differences between the numbers on the scale represent equal differences in the magnitude of the variable. Any object with zero value means complete absence of the characteristics in the object. In interval scale, one cannot compute ratio due to unavailability of property of absolute zero. For example, one cannot compute the ratio of different temperature values in a room as it is calculated on an interval scale, but in ratio scale one can do this. In the following section, some self-check multiple choice questions are given for practice purpose. This will help the reader to test one knowledge about different measure of scales. If you are unable to. 12. Statistical applications in environmental sciences. Answer. Four. Summary. In this module, we try to give an in-depth knowledge of different measure of scales. Different scales are discussed with examples that help the reader to understand the topic in an easy manner. In the previous section, different scales are compared in terms of their feature and properties that they possess. As we are aware of the importance of this topic in the statistics question and answer part will help you to check understanding of this topic. 5. Suggested readings.